Hello everyone. In this video we will do more examples of integrating products of powers of sine and cosine, and we will see that sometimes it's better to combine some of these tricks and techniques and get some more integrals done. Okay, let me start with the first one. Here I have secant squared to the power 5 times sine to the power 3. Well, remember that secant x is 1 over cosine x. So in other words, our integral is 1 over cosine to the power 5x times sine of 3 x. Well, when one of the powers is odd, remember that we can use the substitution u equal to sine x or u equal to cosine x, yes? Uh, Here, the power of cosine is negative, but since the power of sine is positive and odd number, we can't do exact same trick here. So I will use u substitution, setting u to be cosine x. Then as a result of that, du is going to be minus sine x dx. And that minus sine x, we can generate it by separating one of these powers. So I get sine squared x here, then sine x dx. Well, this is not du, there is a minus sign missing. Here I will get 1 over u to the power 5. How about this one? Well, use the simple identity that sine squared x is equal to 1 minus cosine squared x. So in that way, this is going to be 1 minus u squared. So having all the components set up there, I have now the u integral. Well, I will put minus sign out there. And well, this may seem a little bit strange, but you can separate the denominator there. Well, let me put this minus inside for each one separately. U squared over u to the power 5 du, and while this is minus u to the power negative 5 plus u to the power negative 3 du. Use power rules, negative 1 over negative 5 plus 1 u to the power negative 5 plus 1 plus 1 over negative 3 plus 1 u to the power negative 3 plus 1 plus c. And then from there, I get 1 over 4 u to the power negative 4 plus, or well, the minus comes in here, u to the power negative 2, negative 2. Well, in other words, I have 1 over 4 u to the power 4 minus 1 over, did I use that minus already? Yes, I did use this minus, so I didn't need to put that negative there. So u squared plus c. Okay, now my substitution is not complete unless I plug in back my original function here into u. So this is 4x minus 1 over 2 cosine squared x plus c. Well, you can simplify a little bit more and write this one as secant to the power 4x over 4 minus secant to the power 2x over 2 plus c. Okay. How about the other one? Okay, so I see another example here. I have sine times cosine. the first thing should catch your eye is that the angles are different. When the angles are different, we have to use the product rule there. Yes, product formula for sine and cosine. But what about the powers? There are powers here. Well, since the powers are the same, the first thing I can do is I can write one power only for this, and then now use the product rule over there. So it will be product formula. So this will be cosine of in this case this is sine cosine, then the result will be sums of two sines, half of sine of a minus b. A is 2, b is 3, so that will be minus x plus half of sine of sums of those ones, 5x squared dx. Okay, there's no other way around this. So we do that first, and then this is squared, a plus b squared, so expand. So this will give me 1/4 of sine squared negative x plus 2ab, so 2 times 1/4 is just 1/2 sine of negative x sine of 5x plus 1/4 sine squared of 5x dx. Well, look at the first one here. This is so I can use the property sine of minus x is equal to minus sine x. So as a result of that, sine squared of minus x, which is negative sine x squared, this will be sine squared x. So let me just fix these powers and separate each integral. So this will be 1/4 integral of sine squared x dx. The second one will be minus 1/2 integral of sine of x sine of 5x. The third one will be 1/4 integral of sine squared of 5x dx. Now I have three integrals. Each one has different format. The first one is one of those integrals that the powers of sine and cosine are positive, so we use the half angle or power reducing identities. Sine squared of x is half minus half of I can write 1/2. Let me just write that formula. Half of 1 minus cosine 2x. Yeah. So using that, then I will get 1/8 integral of 1 minus cosine of 2x dx. That's the first integral. The second integral, on the other hand, well, this is product of sine and sine. Yes, so I need to use one of those product rules, product formulas for sine and cosine. So if both of them are sine, this will be differences of two cosines, a minus b, x minus half of cosine a plus b times x. Okay, so this gives me, well, I will factor out that half, so I will write 1/4 integral. A is 1, b is 5, so this is cosine of 1 minus 4 negative 4x, 1 minus 5 is negative 5x, minus cosine of a plus b, so 6x dx. Now we can handle each one of those terms separately. Plus, well, the last one is also like the first one. I will use half angle or power reducing formulas. Sine squared of something is half of, that's why I put 1 over 8. 1 minus cosine of twice as that angle, so that is 10x dx. Okay, having everything set up, now I can go ahead and integrate one by one. 1 over 8x is the first term, minus integral of cosine x. Remember that cosine mx is 1 over m sine of mx. This is when m is not equal to 0. So I will have, there's 1 over 8 outside and there's 2 there. So 1 over 16 sine of 2x there, minus. The same story repeats itself here. Yes, so it is 1 over 16. This is plus sine of negative 4x. There is another minus. This is plus 1 over 4, negative 1 over 4 were outside. I multiply inside. There's 1 over 6 there. So this is 1 over 24 sine of 6x. Plus 1 over 8x minus 1 over 8 is already there. There will be 1 over 10 there. So 1 over 80 sine of 10x plus c. You can definitely simplify these terms, but I will leave it like that because for me the important thing was to apply these tricks. And this example shows that sometimes you have to bring all your toolbox, everything, even power, odd power, different angles, and so on. Okay, so these were 2 examples just to cover all the things that we learned about integral of products of different powers of sine and cosine.